Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about measurements and calculation in chemistry. So what is measurement? You know, quantitative observation and one is qualitative observation. So measurement is related to quantitative observation. Quantitative. Remember, quantitative observation. And then if you know the quantitative observation, then comparison based on the accepted scale, and it has two parts, the numbers and the unit. Number tells comparisons, unit tells scale. So you should know the exact numbers for the comparisons, and you should know the scale in which you have measured. Now, scientific notation. What is scientific notation? Scientific notation, you know, the technique used to express very large or very small number based on powers of 10. To compare numbers written in scientific notations, first compare exponents of 10 and then compare numbers. Now, writing numbers in scientific notation, you need these 4 points is very important. Locate the decimal point first, then move the decimal point to the right of the non-zero digit in the largest place. Then the new number is now between 1 and 10. Multiply the new numbers by 10 to the power n, where n is the number of places you moved the decimal point. Then determine the sign on the exponent n. If the decimal point was moved left, just remember, if the decimal point was moved, remember, n is positive. If the decimal point was moved right, n is negative. If the decimal point was not moved, n is 0. These points is important for you for signature or sign of positive and negative and neutral. Now, determine the sign of n of 10 to the power n. If n is positive, the decimal point will move to the right. If n is negative, the decimal point will move to left. You should also know that determine the value of exponents of 10. It tells the number of places to move the decimal point. Then move the decimal point and rewrite the number. Now, related units in the metric system. All units in the metric system are related to fundamentals unit by power of 10. The power of 10 is indicated by a prefix. The prefixes are always the same regardless of the fundamentals unit. So you can see here physical quantity, name of units and abbreviations. Mass, kilogram, kg, length, meter, time, second, temperature, Kelvin. Now this is the prefix mega, indicated by capital M, meaning 1 and 60, written in scientific notation 10 to the power 6. Kilo, represented by a small k. This 1000, scientific notations, you have write 10 to the power 3. Deci, symbol small d, meaning 0.1. In scientific notation 10 to the power minus 1. Centi, symbols small c, meaning 0.01, and power of 10 in scientific notation 10 to the minus 2. Milli, small m, it means 0.001, the power 10 to the minus 3. Micro, represented by mu, 0.000001, 10 to the minus 6. Nano, represented by n, meaning 0.0000000001, represented by 10 to the minus 9. Now length. You know, my friends, SI unit of length is meter, about 3.5 inches longer than a yard. 1 meter is equal to 110 millions, the distance from the North Pole to the equator. Distance between mark on a standard meter rod in Paris wavelength and distance covered by a certain number of wavelength of a speed of color of light. So commonly use centimeter. So 1 meter is equal to 100 centimeter. 1 centimeter is equal to 0.01 meter is equal to 10 mm. 1 inch is equal to 2.54 centimeter exactly. Now metric system for measurement length. You have unit kilometer, symbol small k, small m, meter, small m, decimeter, d and m, centimeter, cm, millimeter, mm, micrometer, micro m, and nanometer, nanometer. All are in a small. Then equivalent 1000 meter or 10 to the power 3 meter, 1 meter or 1 meter is like that. 0.1 meter or 10 to the power minus 1 meter, 0.01 meter or 10 to the power minus 2 meter, 0.001 meter or 10 to the power minus 3 meter, and so on. So artist's conception of the lost Mars climate orbiters. Unit is very important role which play very important role in science because we are working globally. So if you write any unit, you have to write clearly. So this one phenomenon happened due to misconceptions of the unit. Now volume. Measurement of the amounts of three-dimensional space occupied by a substance. The SI unit of volume is cubic meter. Commonly measures solid volume in cubic centimeter. 1 cubic meter is equal to 10 to the power 6 cubic centimeter. 1 cubic centimeter is equal to 10 to the power minus 6 cubic meter, which is equal to this. You know, my friend, commonly measures volume in liquids or gas volume in millimeters. So 1 liter is slightly larger than 1 quart. 1 liter is equal to 1 deci cubic liter, 1000 milliliter, and to the power 3 milliliter. 1 milliliter is equal to 0.001 liter and to the power minus 3 liter. 1 milliliter is equal to 1 cubic centimeter. Now you can see in this figure, this small portion 1 cubic meter is equal to 1 liter, 1 cubic centimeter is equal to 1 milliliter. So this is 1 centimeter, this centimeter, 1 centimeter. So 1 cubic centimeter. So largest drawing represent a cube that has 1 meter in length and volume of 1 cubic centimeter. The middle size cube has sides 1 decimeter in length and volume of 1 cubic decimeter. The smallest cube has sides 1 centimeter in length and a volume of 1 cubic centimeter. Now, how you measure the volume? We have the measuring cylinder in the laboratory. You can see here, this is the graduated, means 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 milliliter. And different types of measuring cylinder available in the laboratory. So this is the 100 milliliter graduated cylinder. Now friends, mass. Measures of the amount of matter present in an object, which is the SI unit of mass is kilograms. Commonly measure mass in grams or milligrams. So 1 kg is equal to this amounts of pounds. 1 ILB is equal to this grams. So 1 kg is equal to 1000 gram, 10 to the minus 3 gram. 1 gram is equal to 10,000 milligram, 10 to the power 3 gram milligram. 1 gram is equal to 0.001 kg and 10 to the minus 3 kg. 1 milligram is equal to 0.001 gram is equal to 10 to the minus 3 gram. So do the practice. It will come if you do the practice. Now friends, you know the kilogram symbol kg, gram g, and milligram milligram. So gram equivalent 1000 gram is equal to 10 to the 3 grams is equal to 1 kg, and 0.001 gram is equal to 10 to the minus 3 gram is equal to 1 milligram. So length, a dime is 1 mm thick and quartet is 2.5 centimeter in diameter. The average height of the adult man is 1.8 meter. Mass, a nickel has a mass of about 5 grams, and so on. English metric and English equivalents. So length, mass in kg, volume in liter. Now temperature is also very important physical quantity, which is measured in Fahrenheit scale. Water freezing point 32 Fahrenheit, boiling point 212 freezing point. In Celsius scale, temperature unit larger than the Fahrenheit, water freezing point 0 degrees Celsius, boiling point 100 degrees Celsius. In Kelvin scale, temperature unit same size as Celsius, water freezing point 273 Kelvin and boiling point 373 Kelvin. So this is the temperature in Fahrenheit, in Celsius, in Kelvin. So you have to measure the thermometer based on the three temperature scale: ice, water and boiling water. Now my friends, certainty in measurements. The measurements always has some amount of uncertainty. Uncertainty comes from limitation of the techniques used for comparison. To understand how reliable a measurement is, we need to understand the limitation of the measurements. Now, reporting measurements. To indicate the uncertainty of a single measurement, scientists use a system called significant figure. And this is very important for you. The last digit written in a measurement is the number that is considered to be uncertain. Unless stated otherwise, the uncertainty in the last digit is plus minus 1. Now, rules for counting significant figure. Non-zero integers are always significant. 0 have three criteria. Leading 0 never count as significant figure. Captive embedded zeros are always significant. Trailing 0 are significant if the number has a decimal point. Exact number have an unlimited number of significant figures. Now, rules for rounding off. If the digit to be removed is less than 5, the preceding digits stay the same. Is equal to or greater than 5, the preceding digits increase by 1. In a series of calculation, carry the extra digit to the final results and then round off. Don't forget to add place holding 0 if the necessary to keep value the same. Now, meaning of exact number. Now you know friends. Now friend, exact number. Exact number are number known with certainty, unlimited number of significant figures, and they are either counting number of side on a square, or defined 10 centimeter, 1 meter, and so on. You can see here. So calculation with significant figure. Calculators, computers do not know about significant figures. So exact number do not affect the numbers of significant figure in an answer. Answer to the calculation must be rounded to the proper number of significant figure. Round at the end of the calculation. So multiplication division with significant figures. Results has the same number of significant figure as the measurement with the smallest number of significant figure. You know my friend, count the number of significant figure in each measurement. So round the results so it has the same number of significant figure as the measurement with the smallest number of significant figure. Here this is 2 sig figs, here 3 sig figs, so answer to be 2 sig figs. Now adding subtracting number with significant figure. Result is limited by number with the smallest number of significant decimal places. Find last significant figure in each measurement. Find which one is the leftmost. So round answer to the measurement decimal places. So this is the precise 10 places, precise 0.1 places here. So this is the answer, 10 places. Now problem solving and dimensional analysis. Many problems in chemistry involving using equivalence statement to convert one unit of measurement to another. Conversion factors are relationship between two units, may be exact or measures. Both parts of the conversion factor should have the same number of significant figures. So conversion factor generated from equivalence point is 1 inch is equal to 2.5 centimeter. This is the conversion factor. So arrange conversion factor, so a starting unit cancel. Arrange conversion factor, so a starting unit is on the bottom of the conversion factor, and may string conversions factor. Now conversion one unit to another. Find the relationship between the starting and goal units. Write equivalent statement of each relationship. Write a conversion factor for each equivalence statement and arrange the conversion factor to cancel a starting unit and results in goals. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.